Hey Brian, I wanted to give you a couple quick videos on how you can prepare for tomorrow night's study session. And this is going to be specifically in relation to the Taylor series and the Maclaurin series. So just write a couple things down here, and if you want to pause the video, feel free to do that as you're going along and writing down your notes. So we're going to assume that we have some function, we'll call it f of x, and that f of x is a power series. So we'll write that down. This is really important for working with the Taylor and the Maclaurin. F of x must be a power series. We'll call that f of x equals the sum from n equals 0 to positive infinity, a sub n times x minus c to the nth power. If that's true, then x must be in some interval. We'll call this the low side of interval, and we'll call this the high side of the interval. Now this interval can be negative infinity to positive infinity, it can be 0 to 2, it can be negative 1 to 1. Whatever the case it happens to be for wherever our function converges, x must be somewhere in between there. Okay, now if that's the case, then our a sub n, which we have right here, we can write it in such a way. A sub n equals some derivative of some derivative of f of c divided by n factorial. Now, what do I mean by nth derivative? We're talking about first derivative, second derivative, third derivative, 15th derivative, whatever the case is, until it goes on forever up to infinity. This is what we can say is the case. We can also then say that the function of x equals the original function that we have at point C, and we'll talk about that here in just a second, plus the first derivative of f with respect to c times x minus c, plus the second derivative of f with respect to c times x minus c squared. This time we're going to divide it by 2 factorial. That's just 2, of course. So then let's keep going a couple more. So then we can say the third derivative of c with respect to x minus c cubed over 3 factorial. And we'll do one more, plus the fourth derivative. Now, instead of writing 4 little hash marks, the way that this is denoted is you'll do it like this. When you get up to 4, you'll want to denote it like this. This indicates that it's the fourth derivative of c times x minus c to the 4th power over 4 factorial. And then, of course, that series goes on and on and on forever. What we can then do is we can then say that this, the way that this is written here, even though it's not written here, I can say that this is actually 1 factorial. 1 factorial, of course, is just 1. I can also say that this piece here is 0 factorial. That, of course, is also just 1. So what you notice here is that when we've come back and we've written this piece up here where c is the constant that we're going to be looking for, we can then write this in such a series. The sum from n equals 0 up to positive infinity of some derivative of n with respect to c times x minus c to the n all over n factorial. Now, what is the difference between the Taylor series and the Maclaurin series? The only difference is this. This that I have here, this is the Taylor series. The Maclaurin series is almost exactly the same. The only difference is this c right here is 0. So this is where c equals 0. And then we would say that is then simply the sum from n equals 0 to positive infinity of the same set of derivatives with respect to c, specifically with respect to 0, of x minus 0. That doesn't really, it's not really important for us to keep that, so we can then just say x to the n, and then we still have that divided by n factorial. So these are the two differences, and I'll kind of write that like that so you can see the whole piece here. I'll slide this up just like that, and if you want to pause it here, I'll start a new video at this point so you can at least copy this piece down. But again, here the main difference between Taylor and the Maclaurin is that the Maclaurin has it such that c is specifically equal to 0. It is a special case of the Taylor series.